Alright, so we're going to take a look at turning points. So here we're asked to find the turning point of y equals e to the power of 3x squared and determine if this is a max or a min. Alright, so we mentioned this very briefly. Actually the second one of these, the max or min, we didn't really mention, but anyway. So for the turning point, so a turning point is a max or a minimum point. So if you take a graph like that, there's a turning point here, and there's a turning point here. The turning point is when it changes from going up to going down, or when it changes from coming down to going back up, when it turns. And we mentioned this, that the special thing about a turning point is that if you look at the tangent at the turning point, that the tangent at the turning point is horizontal. So at these points the tangent is going up, at these points the tangent is coming down. At the turning point the tangent is horizontal. And we know that the slope of the tangent is dy dx. So at the turning point dy dx is equal to 0. So at the turning point dy dx equals 0. So if you want to find the turning point, if you want to find the maximum point or minimum point, you find dy dx and then you put it equal to 0. So here we're going to use the chain rule, so dy dx equals. Now remember that the derivative of e to the power of x is equal to itself. When you differentiate e to the power of x, you get e to the power of x back again. So using the chain rule, if I have e to a complicated power, the first thing is I get e to that complicated power back again when I differentiate. And then as ever, I need to multiply by the derivative of this power here. Alright, so I need to differentiate that power. So when you differentiate 3x squared, you get 6x. Alright, and that's the derivative. Now, that's the first step. In order to find the turning point, I'm going to set that equal to 0. So it's equal to 0 at the turning point. And what I need to do now is I need to solve that. Well, we have two things multiplying giving me 0. So that means e to the power of 3x squared equals 0 or 6x equals 0. So once again, we're finished the differentiation. Differentiation is done. We're now doing algebra. So if you get your calculator and you try putting in any power you want into e, so e to the power of anything, you're never going to get 0. Okay, so this left hand one, this is never actually going to happen. That's impossible. So the only possibility is that 6x is equal to 0 divided by 6. That means x is 0. Okay, well we were asked for a point, a turning point, so we better find the y coordinate. So y, if you go right back up to the start up here, y is e to the power of 3x squared. So when x is 0, that's e to the power of 3 times 0 squared, which is e to the power of 0, and we should know that anything to the power of 0 is 1. So the turning point, is the point 0, 1. Okay, that's the first bit of the question done. Alright, so for the turning point, you find dy dx, you set it equal to 0, and you find what x must be. Alright, so this is the turning point done here. So we find dy dx, differentiate this thing using the chain rule, find dy dx, put it equal to 0, and find what x has to be. Okay, so that's the turning point. The second bit of the question said figure out if it's a max or a min. Now this we did not mention. Okay, so for this we need to look at the second derivative. So if dy dx is equal to 0, okay, then if the second derivative is bigger than 0, that means you've got yourself a min, a local min, like this point up here is a minimum point. And if d2y dx squared is less than 0, you've got yourself a max. Okay, now we did, I think one day in class we did actually go through this, but we never really wrote it down or talked about it too much, so we'll do this example anyway. We might do one or two others. So what we need to do here is find the second derivative. Okay, so just to remind ourselves, we're just going to write down again what dy dx is. So looking back up here, we're just going to copy it from here. So it's e to the power 3x squared times 6x. Okay, so that's dy dx. Now to get the second derivative, we want to differentiate this, and that's u by v. Okay, so u is equal to e to the power 3x squared. So du dx is the derivative of this thing. So it's e to the same power again, multiplied by the derivative of what's up there. So that's du dx. V is a little bit easier. So v is equal to 6x. So dv dx is equal to 6. Alright, so we start filling in. So the second derivative then, d2y dx squared, is going to be u times dv dx plus v times du dx. Okay, so that's u, so e to the power 3x squared times dv dx, which is 6, plus v, which is 6x, times du dx, which is e to the power 3x squared times 6x. Now, this looks horribly complicated, but there is good news. The good news is that we don't really care about, we're not trying to solve this thing in general. Get rid of that. We're not trying to put this equal to 0 and solve. Alright, all we're doing is we're saying when, at the point we're interested in, at the turning point, is this thing here, positive or negative? So, at the turning point, and remember at the turning point, that's at the point where x is 0. So at x equals 0, d2y dx squared is equal to e to the power of 3 by 0 squared times 6 plus 6 times 0 by all this other stuff. Now, we don't actually care what all this other stuff is because 6 times 0 is 0. By anything, it's going to give me 0. This whole second thing here is going to be 0. This is e to the power 0 by 6 plus 0. E to the power 0 is 1, so that's 1 times 6. That's equal to 6. So the second derivative is greater than 0. So therefore, because the second derivative is greater than 0, we have a min, or what's called a local min, at the point 0, 1. And that's the end of the question. So just to kind of recap on it very quickly, for the start of the question, to get the turning points, find dy dx, put it equal to 0 and solve the equation. Alright, so we have, because we used the chain rule, we had two things multiplied together, so then either the first thing is 0 or the second thing is 0, and e to a power can never ever be 0. It can never be negative, it can never be 0. It's always positive. To find, because it was the point we were asked for, we sub that value of x back in at the start and we get a value for y, so then we have the coordinates of our point. Okay, for the second derivative, it's kind of the opposite of what you'd expect. So you look at d2y dx squared. If it's bigger than 0, you have a local min. If it's less than 0, you have a local max. So that's what we do. We differentiate. We take the derivative, we differentiate it again using the product rule, and we fill in x equals 0. And when we do that, we end up with a value of 6, which is bigger than 0, and that means we have a local min. So in one of the other clips, we might explain where this comes from, and where this comes from, and also what happens if you have d2y dx squared equals 0, which is obviously the third possibility. All right.